I met a couple who made a $350,000 animatronic robot that purposely does nothing useful. So, who is this couple and what's it for? And why did they do this? And why did they spend so much money? Well, it turns out that animatronic robots in theme parks are disappearing. And if you don't believe me, keep listening because it's actually true. So, when they realized this, the couple we're about to meet came up with a plan to bring them back. That's just a little bit of what you're going to learn today as we introduce you to two amazing people, Brian Burns and Rebecca Burns from Catalyst Engineering in Atlanta. This is their story. We bring you now to the 2023 IAAPA trade show in Orlando, where we met this couple and their team of engineers as they discussed their capabilities as a company and their plans to bring back animatronics to theme parks.
I'm Brian Burns. I'm the principal mechanical engineer at Catalyst Engineering.
Hey, I'm Rebecca Burns. I'm the operations manager for Catalyst Engineering.
We design and build turnkey animatronic products and equipment. So it could be animatronic animals or show action equipment like moving doors.
Now, before we go any further, I have to tell you that at the beginning of this interview, you're going to hear what seems like a very young married couple, probably in their early 30s, who are just building their company. Their youthful exuberance is evident as they talk to me and each other about how they got started. But don't let that fool you because the more I got to know them and the more I listened, the more I realized how capable they are as a company. But the first question I asked was how they got their start. And that's how the conversation really began.
Yeah, I did the Disney College program in 2010. I was selling ice cream in Epcot, and I was thinking, wow, I kind of like this themed entertainment stuff. I'd like to do this for a living.
And then I met him, and he introduced me to the world of themed entertainment. I was like, oh, this is a pretty cool industry. I would like to join it at some point, so maybe we should do our own thing.
So while Rebecca dreamed, Brian learned a valuable life lesson just selling ice cream at Epcot. That there's value in every job you do, and there's always something that can help you down the road.
I look at schematics now, and I can point out the kitchens and the bag and boxes, and whatever's back there. I'd never underestimate like what a job might bring to your career later. So started off on the Disney College program, and I went back to school, and I won a grant for building a small animatronic dragon. I took that into grad school, got another grant for during grad school to further the animatronic dragon. The animatronic dragon gained attention from Disney, so I left grad school and went to Disney in California. From there, I went to Animax in Nashville, and then from Nashville, I went to Florida with Roush Entertainment Systems, and then
You forgot Universal.
Oh no, I forgot. I didn't mean to forget Universal. It was an internship. But it was awesome. I love it.
It was a cool one. He got to work on the Harry Potter stuff. So
I interned in 2014 with Universal during the opening of Diagon Alley, and that was super fun. Further
in the car, what car is that? It was like a motorcycle car.
Oh yeah. Sleeping in the motorcycle car while we're doing final testing before the park opens. Lots of overnights. Yeah. It was fun.
So eventually, life and family roots called them back to their home in Georgia. But their hearts stayed true to their calling in themed entertainment. And there, they started a brand new animatronics company.
Really, this is a lot personal as well. So our whole family's from Georgia. We, started a family, and we wanted to, get back to Georgia, but we didn't want to let theme parks go. So we thought, you know what? I'm pretty good at this animatronic stuff. Why don't we start animatronics in Georgia?
And I had nothing to do with themed entertainment before this point, and was just living vicariously through Brian, and was like, oh, we could totally do this. This seems easy.
Now, this is where it gets interesting. And we get to see a little bit of the technical expertise that Brian Burns has. Because I asked Brian how they make animatronics that last, and this was his answer.
Well, as my good friend would say, Leigh Fawn, it's all about Gruebler's Count.
Gruebler's Count? What is this sorcery? Well, turns out that Gruebler's count is a number that mechanical engineers calculate when evaluating mechanical systems like an animatronic. In a manner of speaking, it tells you how many degrees of freedom an animatronic can move. But it also takes into account the number of constraints it has. For example, a door only really needs one hinge to move properly, but doors typically have three hinges, which are more than are truly necessary. It's overconstrained. Now, animatronics are a lot more complicated and have a lot more degrees of freedom of movement than a door. So, engineers calculate this number to ensure that a design is efficient and strong without being too redundant. That's Gruebler's count. Anyway, back to our story.
And so we make sure we don't over-constrain our designs and joints. We design them in a way that compensate for misalignment and little part inaccuracies. And
Gruebler's count.
yeah, so check that out. Leifon wrote a book about that. It's called How to Make Machines or Mechanisms That Last a Lifetime. And Leifon released that a couple of years ago. We worked together at Roush. And so he's been a big influence of mine for, on the technical side especially. And, love working with him, and we still work with him now.
So, as you can tell, we're really starting to see a lot into how Brian thinks and his understanding about how to machine his animatronics properly, especially when it comes to materials and those small imperfections that often cause machines to fail.
Nothing's perfect. There's, if you machine a flat plate, it's not flat 0.0000. There's some non-flatness associated with that. So, when we attach parts to that, are we accounting for all this tolerance stack up? And we design machines and joints that couple together that can handle, all that tolerance misalignment, so that we're not adding extra load into our system that we don't know is there. So, and that's these are the things that turns a machine that's lasted thousands of cycles into millions of cycles.
Now, it's important to note that an animatronic for a movie may need to only work once for a shot that lasts just a few seconds. And at a museum, it may need to run for a few hours a day, but at a theme park, it needs to run sometimes up to 16 hours a day, 365 days a year, and that's a different way of thinking.
Yeah, that's a whole different animal. So, there's not many machines that are running that, normal people see constantly that don't stop. It's millions and millions of cycles. So, the little stresses matter when it comes to that. So, most of the actuators and stuff that we pick out, they're rated for like 20,000 hours. That gets us about 5 years of life. And, the main structures, though, is the key point that we want those to last, a lifetime. So we design them so that, aluminum doesn't have an endurance limit, but, there sort of is one when you design, to a certain stress level. Once you get your joint design set up, like, per Gruebler's count, where nothing's over-constrained or under-constrained, then it's, picking the right materials and making sure that, your loads that you're anticipating in your system are actually the ones that are in the system, and that you're choosing materials that can handle the forces and that they can handle the stresses that they're seeing.
So, Brian and Rebecca are doing the right things in order to make their animatronics have the endurance to handle the long days required for theme park operations. But they've also got another trick up their sleeve. And that's because their engineers build the animatronics themselves. I think you'll see the advantages.
We like for our engineers to also assemble the product, and that makes better design engineers. So, when you're designing initially, you're really just thinking about functionality of the system that you're producing. It's hard to think about assembly and maintenance, but when all of our engineers are actually assembling the product that we're designing, it really forces you to think about tool access and maintenance long term. And so our engineers are, I believe, designing better products than many other companies because, we don't have a separate assembly department. We're small and lean, but, I think we have, the best experience to apply to the design.
Now, I know I promised you a robot, and trust me, that's coming. But sometimes these conversations take an unexpected turn that are worth including. Little moments that just show the personal side to this business. And it all started when I asked Rebecca what she does.
What do I do? I purchase all the parts. I do the accounting. Well, I do the bookkeeping, I guess. I do, what else do I do? Legal.
Social media.
Social media.
You posted a question directly related to this a couple weeks ago.
Oh yeah, I did.
It was like, what material is has the best strength to weight ratio? And the answer was?
I don't remember.
You set up the quiz.
Yeah. No, you don't ever answer the answer of the question. I never put the answer.
All right, for those listening, it was either 70-75 or 60-61 aluminum. I don't remember actually which one. It's one of the two. Aluminum's awesome.
I stopped doing the questions because it was just like, there were smarter people answering it and saying that's wrong. I'm like, well, I tried.
So it's clear that Brian and Rebecca have a lot of technical expertise when it comes to the design of animatronics, but starting a new company isn't without its challenges. So they started solving those problems step by step. I asked them what it was like in the early days of their company, and this is what they said.
See, early days. Were there challenges in the early days? We're in the early days. I mean, we're young. We're 2 years old. But I guess starting off, the questions are like, hey, how do we actually like win contracts? And really like what we found out is you need space. So we acquired a space and we immediately started getting contracts. So I think, really it's all about cash flow in the beginning is like the biggest challenge. It's how we need money to hire people and we need money to buy a building, or lease a building. But we need, work to get the money. Which one comes first? And it's sort of a little bit of both at the same time. So you kind of like, okay, we can front a little bit. That's just enough to get a little bit of work so we can hire one more person. And then, okay, we got a little bit more work so we can hire one more person. And so, it's kind of we chug along and keep growing. So, we're excited to keep going.
So, like any business in its infancy, there are some growing pains, but it turns out that being a young and fresh company has a lot of advantages too, because they can start to attack old problems in new ways.
I think we're, super excited.
We're taking like the old approach was like pneumatic, and and we're like focusing more on electric and trying to still get the like design that people want, but for less money. And so that's what we're trying to do.
It's like with any industry, like automobiles, like the first cars were all manufactured, every piece of the car is all manufactured in one facility. And then slowly you would have like, a company specialized in transmissions and they make their own company. And then someone specializes in tires and they make their own company. And we see this as just kind of the next step here. We're specializing in mechanical design, and assembly. And, here we are with our own company. And it's simple stuff like, a lot of the other companies, they house their own machine shop. Well, we've realized, there's so many machine shops that just produce custom parts have cropped up all over. And with an in-house shop where you're not producing parts at 100% capacity, you can't come close to the cost and the prices that they can produce parts for. So, we don't have that overhead, so we can run leaner and by leveraging those machine shops that exist. So, it's really about specialization so we can be more efficient.
Now, this sounds great, but there's still a big problem in the industry right now. Because over the last 40 years, the animatronics and theme parks have been disappearing because the price keeps skyrocketing. The big companies like Disney and Universal still buy animatronics, but they buy fewer of them. And the smaller parks are simply priced out of the market. So Brian and Rebecca are attacking the problem of skyrocketing costs head on.
I think our niche is we can build the best animatronics, the most efficient and for the best price.
Still satisfying the design intent with how we're mechanically designing.
Yeah, I think like recently, I guess over the past couple of decades, I feel that like animatronics prices have like exploded, because more and more requirements have been thrown on top of animatronics and more overhead has been thrown on top of that. And really, we want to try to lean that out and say, okay, how can we build this more efficiently so we can get more animatronics in the parks? I mean, it's like you don't see any more rides opening like Pirates of the Caribbean with, hundreds of figures in it because it's too costly to build that many figures. The way we're currently building them, we want to try to figure out how do we get back to that? How can we build hundreds of figures for a modern day budget?
I have to admit that I was skeptical at first that animatronics and theme parks are disappearing. But then we did a podcast with Linda Alcorn, who confirmed this fact. She was the very first female electronics engineer that WED Enterprises, now called Walt Disney Imagineering, hired for Epcot. She was quite the legend in her own right. Linda made the very astute point that Disney put 188 animatronics in that attraction and that they haven't come close to that mark since. Now, that's just Disney, but what about other park brands? Universal tends to produce a lot of story-driven attractions too. So while rides at Universal like Men in Black have 127 animated figures, a lot of their latest attractions have no animatronics at all. They've gone to ride films instead of live animatronics. So, doing some historical checking, this is what I found. Back in 1964, It's a Small World opened with just under 300 animatronics, even as simple as they were. Then Pirates of the Caribbean opened in 1967 with 120 animatronics. 2 years later, The Haunted Mansion opened with 109, and then in 1976, Jungle Cruise expanded to about 119 animatronics. But in the 1980s, those numbers trended downward. Horizons at Epcot had 54 animatronics, and Spaceship Earth had 66. Later that same decade, Splash Mountain opened at Disneyland with 103 animated figures, but a lot of those were reused from the shuttered attraction America Sings. World of Motion was the high mark at 188. But what about the last 20 years? With costs going up, even the newest and most advanced attractions like Radiator Springs Racers and Rise of the Resistance only had 23 and 20 animatronic characters, respectively. So, over time, it seems that the number of animatronic figures has gone down across the board. Will this trend continue? This remains to be seen, but cost seems to be a factor. But are those the only factors? You could argue that the number of animatronic figures are dependent on the story you're trying to tell, and in some cultures, like in China, I've heard it's actually preferred to hire a live person to play a part and give them the job, rather than replace them with a robot. So culture has something to do with it as well. But even so, the last high watermark for animatronics in an attraction still stands at 188 with World of Motion. At the time of this recording, over 40 years ago. In short, Brian has a point. Animatronics are disappearing in the parks, so they want to make them affordable again while retaining the functionality of a multi-million-dollar animatronic figure. A noble goal, so that it's possible to do another attraction like World of Motion again. But that wasn't the only purpose. For Brian and Rebecca, it was also a means to an end. Enter their first product, an animatronic they aptly named Proteus.
Well, the first thing we asked ourselves is like, how is anybody going to know that we can build anything? I mean, I have a lot of friends in the industry, but we can't show everybody else that, hey, we can build a full, complete product. We need to build something and show everyone. And I love dragons. I built a dragon in grad school. I was like, hey, let's just build a big dragon. And we said, wait, hold on. Why don't we build something that we can also sell? And so we were thinking, well, what's like the most generic thing we can sell? And we're like, well, there's a lot of humanoid type animatronics out there. We can just dress them differently. Maybe let's build a humanoid and have that as both a product and something that we can market, build, and deliver product to.
And a whole product from start to finish, where you have the figure finish at the end as well. So we're not delivering just the mechanical part.
Absolutely. Yep. That's really where it came from. We're trying to figure out how to market the company, but then also like what's actually a product that we can sell and market the company at the same time so it can have a dual purpose.
So with the humanoid platform, we were trying to show that you can get a good product, get the $1 million figure look for a third or half the cost. And so we're showing off that you can create the intent that you want for these cool humanoids that you see in the parks that are $2 or $3 million each for $350,000. So you don't need to have 50 motors or something like that to achieve the movement that you want.
So it turns out that a $350,000 robot isn't expensive. It's actually cheap because of what it replaces. And I have to admit that they seem to have really thought this through because of what they can do with it.
We're not overbuilt, so we took a lot of existing design philosophies and we said, okay, well, that's a lot of extra metal that we don't need, and like, how can we optimize this and make it efficient, because we don't want this to be $1 million robot. So it's really about optimization and efficiency. So that was a driving factor through the whole platform. It has less functions, so we spent a lot of time trying to decide which actuators, which functions do we actually need in this humanoid that actually make, it's the biggest bang for your buck. And, in any animatronic, those last couple functions that we try to squeeze into a figure really cost the most, and it really skyrockets the price, because, when you've got like a one function character, maybe that motor fits great, 2 fits great, and you start to add more and more actuators, and eventually you're starting to really try to have to squeeze things around, and then parts start to become more elaborate, they start to become more expensive, and then if each function was costing you like $5,000 per function initially, those last few that you're squeezing in there are costing like $20,000, $25,000, $30,000, because you're having to shift things around, snake cables around in weird places. And we decided, there's a cutoff for, creative intent and cost. Where's that part, that point, if you're looking at a graph, that cost starts to skyrocket. And we said we're going to stop right there. And that was our driving philosophy for this figure.
But this robot Proteus doesn't just have to be a person. It can be anything. There's an old joke. How many Imagineers does it take to change a light bulb? The answer? Does it have to be a light bulb? So the idea that they can make this animatronic into virtually anything allows an Imagineer to dream, to think big. And now we're going to tell you the secret of how it can be so many things.
We have 25 actually, different joints that we can either lock off or add an actuator to, that we can add motion to. And then we can also space the body up or down, so we can make the humanoid taller or shorter. And so that's where the configurable part comes from. And really, when we're going to dress it to whatever the creative intent is, so it's whatever the buyer wants, we can make them, a pirate, we can make them look like anything, right? What we're looking at now is our male platform, and we've got a female platform that's probably about 50% design, and then after that we're going to start looking at actual faces. As you've probably noticed, this one has a helmet on right now. So the configurability, we're add enough adjustability to meet different creative intents, different motion intents, and different price points. So that's more actuators equals higher price, and more elaborate costume equals higher price.
He was talking about the 25 functions, so you can go up to 25 functions, but it's all for the customer to say, oh, I want the right arm to move or the left leg to move, things like that.
So if the humanoid platform as a standard has a certain amount of capabilities, but if there's anything that's outside of those capabilities, I mean, we do full custom animatronics, so we're able to do that. If you want a humanoid with 6 arms instead of 2, we'd love to help you out on that, right? So we can cover him in fur, and now he's some kind of animal instead. Certainly existing designs that we have on the humanoid, if we can leverage them into custom designs, we do. But if it's completely custom, that's what we love. So it's fun.
Love is a great word, isn't it? When you enjoy your work, there's never a day in your life that actually feels like work. Now, the next question I asked was an innocent one, but the answer was one that I didn't expect. It was one of those delightful moments that sometimes happens in interviews like this, that they clearly regard their robot as useless. What?
Yeah, so the Proteus platform can be used in dark rides or any other theme park attraction. Zooming by, he's telling you, hey, we gotta go like stop this dragon, or whatever we're doing, and or it can be used in like science museums as greeting guests into a new exhibit. We can have them in trade shows to welcome people and gain interest into different booths or museums. Yeah.
Zoos, science museums. What is it? We even said at your personal house.
Oh, so it's actually kind of more fun. So usually when we say like, hey, we're building a humanoid robot, most people go towards like, the useful robots, like they're doing a certain task, like moving boxes or something like. It's like, no. Ours isn't like a useful robot. It's a for entertainment robot. It's different than that. He doesn't walk around. He stays in place. We can configure his foot stance and his look and everything, but he doesn't do anything useful except entertain you, which in itself is useful. I mean, we all kind of
can be useful.
Yeah. And that's the first world, right? We all like are driven towards entertainment, and that's what we spend most of our time trying to like spend our money on is entertainment.
Older people ask, like,
Yeah, that's
so
usually
what's
the
it
question.
do?
What's it do?
And you're like,
Yeah, everybody outside the entertainment industry is like, what are you doing? I'm building a humanoid robot. Oh, awesome. So it like walks around and picks up boxes. You're like, no, it stands still and doesn't do anything useful. And then they were like, well, what's the point? And I was like, just to entertain you. Well, that sounds kind of pointless. And you're like, well, yeah, but people spend a lot of money on that at theme parks. So, once you finally, like point out actually what it is, everybody starts to get it. But at first, everybody's thinking humanoid robot, it should be doing something. You're like, no, wrong humanoid robot.
So now that they had a useless robot, they needed a name for it. But the way they settled on the name Proteus was also interesting. And then they got another laugh when they came to the trade show and found out what was next door.
Yeah, we thought humanoid animatronic sounded kind of bland, so we need some kind of tagline or name. So started researching names and found Proteus as a Greek god who could shapeshift. And so, this being a humanoid that we can configure to look like any other sort of character, Proteus is a shapeshifter that can look like some other human. We thought that name fit perfectly. And it was actually kind of funny. We thought Proteus was pretty unique until we showed up here and I walked one booth over. They're showing off a light fixture called Proteus Excalibur or something like that with like light and fog. And I was like, what are the odds that we're like next to a booth also using the name Proteus? But, completely different industry, or different product, but pretty hilarious nonetheless.
This reminds me of showing up to a wedding and someone else is wearing the same dress as your date. That's life. But even to get to that point, they had a lot of design challenges. But then something happened that saved them months of work, and it only cost them $150 in the process.
Actually, it's funny like how we ended up like with the figure we got, because with most projects that I guess a lot of people like in my industry are used to, like specifically the mechanical engineering process that we're used to, as you'll spend a lot of time sculpting and coming up with like pivot points up front. We started with, I was Googling CAD humanoid 50th percentile, and I found a website that had CAD ready to go for a humanoid and in a solid form, and it had kind of a pivot points all laid out. Downloaded it, bought him for like $150 and downloaded him, and we took that and kept all those pivot points and shelled him and ran with it. So that took that process that we normally spend months on at the beginning, mulling over like pivot points and stuff. Everything that we looked at that's looking at that model was like easy and ready to go.
So sometimes life just hands you those wonderful little blessings that change everything. In their case, it was that amazing find on Google that saved them months of development time. And this helped them to keep costs down. But they're also working to make it easy to maintain and easy to use, which is just as important.
Most animatronics require, like 220 giant plug, something like 3-phase power is something that you need to run it. But this operates on your regular 110 power outlet, like a regular 15 amp breaker. So you could plug this into your kitchen and it will run. And simplicity as well. So is this something that you can replace parts and get replacement parts for as they wear out in the future. Well, do the best we can, but let nothing last forever, right? Bearings are going to wear out. If there's friction involved, it's going to wear out at some point, no matter, Gruebler Count or not, right? But something's going to wear out, so we want it to be replaceable and maintainable as well.
We try to make the process of building and designing him with the customer seamless. So, we try to make it upfront.
Not every client has their own. Not every client has their own engineering team, right? So, for some of the smaller teams that don't have like a full technical staff, we want to be able to provide everything they need to own and operate this figure.
So they've done quite a lot in terms of making Proteus easy to maintain and use, but they're also fixing some problems that a lot of existing animatronics have with sway. I'm sure you've noticed this, but sometimes the way an animatronic moves just doesn't look right. Now, there are exceptions, like with Pirates of the Caribbean, for example. I used to work on that ride. With pirates, you actually want the pirates to sway because they're supposed to be, well, drunk pirates. And so a little sway is acceptable. But other times, you just need them to look right.
There's existing humanoids, and you can see them in Disney and Universal parks if you pay attention to their feet and how they operate, how they do their like body side sway and fore sway motions. And it bothered me how their feet actually move with their motions, and versus if you look at your own legs and sway back and forth, the feet don't move. You can keep your feet planted. So, I spent a long time, trying to figure out what's the joint combination that allows me to keep the feet planted, but lets me side sway, forward sway, and body twist. And that's something we're pretty proud of. That we have a patent pending mechanism that does that, and so we can pivot at the ankles and side sway in a way that doesn't move the feet.
So that's Proteus, an amazing animatronic that can look like virtually anything that they believe will help your park realize significant cost savings compared to a lot of animatronics on the market. And people are taking note because Brian and Rebecca Burns and their company, Catalyst Engineering, won a 2023 IAAPA Brass Ring Award for Best Exhibit with Proteus. That's quite an accomplishment. And there's plenty more to tell about what's coming next for Catalyst Engineering. We're going to tell that story too, but we'll save that for another day. For themedattraction.com, I'd like to thank Brian and Rebecca from Catalyst Engineering for joining us on this podcast. I'm Nate. Thanks for listening.